We are obsessed with black holes. They are the ultimate monsters of the universe. Gravity so strong that not even light can escape. They are the end of the story. But in physics, equations work in two directions. If you film a ball falling to the ground and play it backward, the math still works. Gravity works in reverse just as well as it works forward. So if you take the equations of general relativity that describe a black hole and simply flip the variable for time, you don't get a nothingness. You get a monster. You get a white hole. It is the mathematical inverse of a black hole, a region of space-time that cannot be entered, only exited, a place where gravity pushes out with infinite force. For decades, we thought these were just mathematical ghosts, errors in the chalkboard calculations of Carl Schwarzschild. But then, Einstein and his colleague Nathan Rosen found something strange in the geometry. They realized that the singularity at the bottom of a black hole might not be a dead end. It might be a door. This is the Einstein-Rosen Bridge. Science fiction calls it a wormhole. But physics suggests it is a tunnel connecting 2 points in space-time. Imagine a black hole as a drain. Matter falls in, gets crushed, and disappears from our observable universe. Where does it go? Conservation of information says it can't just be deleted. It has to go somewhere. The theory suggests it flows through the bridge and is violently ejected on the other side, via a white hole. But there is a problem. A reason why many physicists scream impossible. It's called the Second Law of Thermodynamics. The law states that entropy, the measure of disorder, must always increase. If you break an egg, it shatters. It never unshatters. Time has an arrow, and it only points forward towards chaos. A white hole violates this law. It is an object where entropy decreases. It creates order out of chaos. It organizes matter instead of scattering it. To exist, a white hole would have to fight the flow of the entire universe. It would be like a river flowing uphill. However, recent calculations in loop quantum gravity suggest that this violation is temporary. The theory suggests that when a black hole dies, after billions of years of Hawking radiation, it shrinks down to the Planck scale and then bounces outward. It instantly transforms from a black hole into a white hole. This means that white holes aren't happening now. They are happening at the end of time. They are the death rattle of a black hole, spitting out everything it ate over 1 billion years in a single microsecond flash. But here is the terrifying part. That flash, it might look exactly like a Big Bang. This brings us to the cosmological natural selection theory. Think about our Big Bang. It was a moment where a massive amount of matter and energy suddenly exploded out of a single, infinitely dense point. Does that sound familiar? Some physicists, like Nikodem Poplawski, propose that our entire universe is living inside the event horizon of a much larger black hole in a parent universe. What we call the Big Bang was just the moment the star in that higher dimension collapsed, formed a black hole, and spewed us out on the other side. This implies that we are part of a cosmic lineage, universes giving birth to baby universes, passing down physical laws like DNA. It means that black holes aren't death, they are reproductive organs. So if this theory is true, our Big Bang wasn't a beginning. It was just the exhaust pipe of a star collapsing in a higher dimension. But that leads to a terrifying thought. If we are living inside the corpse of a dead star from a parent universe, what happens to us when that parent universe finally fades to black? That is the question that keeps me up at night.